I hope you all are watching my channel and you all are liking the little key points which I am giving after reading your lesson and after practicing the extra questions which you do in your private tuition classes. The lessons which I give will be on your tips if you try to see the video repeatedly, understand the points, and because I emphasize only on the key points of the lesson. And as I told you, welcome to the new subscribers, to the new listeners, to the new students, and to the old ones who are liking it and trying to share and subscribe the channel and go ahead with what I teach. Okay. Now today we have another very interesting lesson of chemistry, and this is also a basic lesson of chemistry. Those who will pursue science in their higher classes, 11th, 12th, and that lesson is, the base of this lesson is actually from 8th standard, as written here, electrolysis, a very, very important lesson, electrolysis. Now, the word electrolysis, as you see, is made up of two words, electric and lysis, something which will break with the help of electrical energy or electricity, electrolysis. Okay. Now, the whole lesson is a very big lesson in your ICSE book. I again emphasize on ICSE book, and I am dividing this lesson in two parts. The first part of the lesson or this video will tell you about what is an electrolyte, what is electrolysis, what are the types of electrolyte, then strong and weak. After that will be what are the terms involved in this lesson which you have to write and recollect and keep on practicing it by writing it. First will be what is an electrolytic cell. In that electrolytic cell, what is found? The electrodes are found. What are the types of electrodes? Then what are the ions which take part in this electrolytic decomposition? Then the complete mechanism of electrolysis, the Arrhenius Theory, the features of Arrhenius Theory. After that comes the characteristic features of electrolysis. After that will be a comparison of electrolytic decomposition to that of ionization. Then into last part of the video will be about electrolytic dissociation of an ionic compound, that is sodium chloride, how it gets electrolyzed, under what conditions, and then comes its comparison with electrolysis of covalent compounds like HCl. Till this part I will be going. The further part of the video will tell you about acids and bases as electrolytes, salts and electrolytes, and in that you will read, I will go for some of the salts electrolysis with their equations, then the applications of electrolysis in terms of electrochemical series, the series for metals which form cations, the series for non-metals which form the anions, and after that will be their applications where they are used, electroplating, electrometallurgy, electrorefining. That will be the next part of the video. So, welcome students again to this lesson, electrolysis. Okay, now keep your ICSE book in front of you. So the first thing I tell you here, that you should keep in mind is the definition of electrolysis with that electrolyte and the types of electrolyte, strong and weak. So what is the example or what definition will you give for electrolysis? You will write here, the term electrolysis is split into two words. Electro means electricity and lysis means breaking. So the process of breaking into ions or molecules with the help of electricity is known as electrolysis, or if I want to tell you another complete definition of electrolysis, you can also write it as, the word electrolysis can be written as the decomposition of a chemical compound by the passage of electricity through its aqueous solution or its molten or in bracket fused state. Aqueous solution or molten state, not in solid state. Okay, and during electrolysis a change is brought about in the compound with the help of electrical energy. So that is about electrolysis, and the other terms which you will come here will be, for example, will be the conductors, the substances which have very high conductivity in the flow of electric current are called as conductors. Now, like metals, their alloys, and certain non-metals are also very good conductors, like graphite, carbon black. They are also very good conductors. Now these conductors under this lesson, electrolysis, are under two types. There are two types of conductors which you should know. One is metallic conductors and another one is electrolytic conductors. Metallic and electrolytic. And next question is here, give the difference between the metallic conductors and electrolytic conductors. Now, the metallic conductors, the flow of electricity takes place due to the flow of electrons from negative to positive pole only in case of metal, negative to positive only in case of metals. Then there is no flow of matter. Matter doesn't take place here. Matter doesn't decompose here only in case of metals. Then conductivity decreases with increase of temperature. The metals, whether they are in solid or liquid state, are good conductors of electricity. Example is copper and zinc. Now its comparison with electrolytic conductors, the flow of electricity takes place due to the flow of positive and negative charges towards the respective electrodes, cathode and anode. Then the matter gets decomposed into ions, breakage into ions. There was no breaking into ions. Then the electrical conduction increases with increase in temperature, and because why it increases? Because the dissociation of the electrolyte into ions increases. Okay, and the electrolytes are good conductors only in aqueous solution or in molten state. Example for this can be copper sulfate, zinc sulfate. So two questions till now. What is electrolysis? What are what are conductors? What are metallic conductors? What are electrolytic conductors? Okay. Now comes the term strong electrolyte versus weak electrolytes, because electrolytes, now another definition should also be here in your mind, should be what are electrolytes? What are electrolytes? That will be the third question. What will you write? What are electrolytes? Electrolytes are electrovalent compounds and also polar covalent compounds that has the ability to form ions in water. So the electrolytes will combine two things. They will combine the covalent compounds as well as electrovalent compounds. Polar covalent compound as well as electrovalent compound. Matlab ionic bonding and covalent bonding. If the previous videos, if you remember, ionic bond and covalent bond. So these all are electrolytes with some exceptions. So now here we will now go for the next comparison between a strong electrolyte and a weak electrolyte, as it's written here, right? Strong electrolyte and a weak electrolyte. Now a strong electrolyte are good conductors of electricity. Weak electrolytes are poor conductors of electricity. Strong electrolytes, they completely dissociate. Here they partially dissociate into ions. Next, the other examples of strong electrolytes can be all the strong acids, all the strong bases like hydrochloric acid, NaOH, electrolysis of lead bromide, which is there in your syllabus, lead sulfate are the examples of strong electrolyte. What about weak electrolyte? Some weak acids like carbonic acids, weak base like ammonium hydroxide, salts like sodium carbonate and sodium bicarbonate. They come under weak electrolytes. So I think till now I gave 5 questions. First, what is electrolysis? Second, what is an electrolyte? Third, what are metallic conductors? What are electrolytic conductors? Fourth, give the comparison between a strong electrolyte and a weak electrolyte. Okay, now we proceed further. As we go ahead, please keep your CBSE or NCERT ICSE book in front of you and come to page number 103. Now here we will come to the next part of the lesson, which is the components of this electrolytic cell. What are the basic components which are involved in this electrolytic cell? See, for this you should always draw one basic diagram which is given in your book. Some basic diagram is given in your book. Try to draw this diagram. If they ask you to draw one electrolytic diagram, now this is just one small electrolytic diagram of a diagram which you should keep in mind, and these are the small experiments which you will do in your lab. This is an electrolytic cell, this is an electrolyte, and as I said, the components are, we have to use 2 electrodes here. Now just now we will be telling you what are the electrodes, and this is the electrolyte, the solution which will conduct the electricity. A circuit will be made and it will be connected to a battery. A voltmeter will be there where the bulb will glow, and the glowing of this bulb will be very, it will blow very strong or it will blow very light as per the electrolyte, strong electrolyte or weak electrolyte. So now I rub this diagram because you have to draw this diagram. If they ask you to draw a typical electrolytic cell, this is a typical electrolytic cell. Okay. Now, first thing here will be the electrodes. 2 types of electrodes, anode and cathode. I take this, if you can see these 2 candles, this green one is the anode, the green pen is the anode, green pen, and the blue pen is the cathode. You can read this lesson by keeping 2 colored pens also with you, then you will not go wrong. The green pen is the anode and the blue pen is the cathode. First term here will be electrodes. I will tell you the features of this. Then will be the ions. What 2 types of ions will be there? One will be anion, another will be cation. Anion and cation. Now we first come to the electrodes. What are electrodes and what are the types of electrodes? Okay. Take your notebook and write. Electrodes allow the electric current to enter or leave the electrolytic solution, and the device in which the electrolyte is carried out is called an electrolytic cell. If they ask you that diagram, what is an electrolytic cell? The device in which the electrolysis is carried out is called an electrolytic cell. And this electrolytic cell also contains a voltmeter, that diagram, with the electrodes, the cathode and anode, and an electrolytic solution, the 5 components of an electrolytic cell. And if they now ask you, tabulate the differences between anode and cathode. First you should write here, the electrodes are 2 in number and they are made up of metals or carbon. The graphite electrodes are also used here, and the electrodes are connected to battery via a key or a switch, and depending on the connection to the battery, the way they are connected, to the positive end or to the negative end, they are classified as the anode or cathode. Now features for anode will be, this electrode is connected to the positive terminal of the battery. So the anode will be the green pen, the positive terminal of the battery, and in this positive terminal of the battery, the electrode hence acquires a positive charge during electrolysis, and the ions which our negatively charged gets attracted here. That is, the anions migrate here to the anode. What will migrate here? The anions will migrate to the anode. Because it is positively charged, it will attract the opposite charge. So the anions will migrate to the anode. Okay. Next, these anions, what they do after they go to the anode, they donate their electrons there at the anode and they get oxidized. So this anode is the oxidizing electrode. Anode is the key word here, is anode is the oxidizing electrode. The non-metals usually go there and they donate their electrons there and it becomes oxidized. And so the oxidizing electrode. The anode is the oxidizing electrode by which the electrons leave the electrolyte. The loss of electrons from an atom or an ion is called oxidation, your previous lesson, and hence the oxidation takes place at anode. Always remember, oxidation reaction takes place of any electrolyte takes place at the anode. For example, chlorine. Chlorine is an ion. It will lose its electron, chlorine, Cl minus Cl, 1 minus. It will lose its electron to become Cl, Cl minus to Cl. That is, the anion will become a cation. Anion will become a neutral atom here. Where? Here. This it will take place at the anode. Always remember this, right? Because we take the example of sodium and chlorine. So here I am taking the example of chlorine, which is given in your book. Next, its comparison with cathode. Now, cathode is the negative. It is the negative terminal. It is attached to the negative terminal of the battery, and this electrode acquires a negative charge during electrolysis because the cations migrate to the cathode. There the anions migrate, here the cations migrate, and these cations which migrate to the cathode, they gain the electrons from the cathode and are reduced. So this cathode is the reducing electrode. Anode is the oxidizing electrode, cathode is the reducing electrode. The cathode is the reducing electrode by which the electrons enter the electrolyte. That is, say for example, here the metal Na1 plus will take one electron and become a neutral atom, Na, sodium. There the chlorine was trying to it became oxidized, and here sodium, chlorine became oxidized and sodium became reduced. Oxidation reduction, redox reaction. So the comparison of anode and cathode. Positive terminal, negative terminal. Oxidizing electrode, reducing electrode. Gain of electron, loss of electron. Okay. Then next is two types of ions. Anions and cations for an electrolytic cell. Anions, for example, the anions, they are the negatively charged ions, first point. They migrate to the anode, second point, and they donate or they lose their electrons to the anode, that is oxidation process, and they get oxidized to neutral atom. That is, like Cl1 minus will give away its one electron and become changed to neutral chlorine atom, Cl, neutral chlorine atom. What about cation? The cation are positively charged ions. They migrate to the cathode. They migrate to the cathode, and during electrolysis, then they accept or gain electrons from the cathode, that is reduction, and they get reduced to a neutral atom. Say sodium, Na1 plus will take one electron, Na1 plus plus 1E gets changed into Na plus, Na, plain Na. There Cl1 minus, say minus 1 electron going away, gets transformed into Cl. Here's Na1 plus plus 1 electron, it gains an electron and it becomes sodium atom, neutral atom. So the comparison of Cl and sodium. So this was about anion and cation, anode and cathode, electrolytic cell. So the next question here is, what is an electrolytic cell? Draw an electrolytic cell, the components of electrolytic cell, explain the difference between cathode and anode, and also the two ions, anions and cations. You should remember this very clearly. I take this green pen as an ion as I told you, and the blue pen as cation, and keep the features in mind. After this, we will go for the characteristic features of an electrolysis, or the Arrhenius theory. Okay. Next part is features of electrolysis. Or whenever you are doing a lesson, do the lesson in parts. Don't complete the lesson or don't revise the entire lesson in one shot. Because if the lesson is very big, you should divide it into segments. Then that clear concepts will be there in your mind. So now we come to the next question, which is often asked here. What are the main points of Arrhenius Electrolytic theory? So what will you write here? The process or mechanism of electrolysis was first explained by the Swedish scientist. He is Arrhenius. And what did he say? The main points. An electrolyte on dissolving in water dissociates into ions, free cations and free anions. Cations are positive and anions are negative, which allow the flow of current through it. Next, this degree of dissociation depends upon the electrolyte and its nature of dissociation. To what extent can it break up? Then all the ions carry an electric charge and are responsible for the flow of electric current through the solution. The amount of electricity conducted by the electrolyte depends upon the concentration of the ions, how strong that electrolyte is. The number of positive charges are always on the ions are equal to the number of negative charges, and thus the solution is electrolytically in equilibrium condition. So I am repeating the points of Arrhenius theory points again because it's very important. So an electrolyte, first point is an electrolyte on dissolving in water will dissociate into free cations, that is positive ions, and anions, that is negative ions. It is the first two ions, the green pen and the blue pen. They will dissociate into two ions, cations and anions, positive and negative. Then what? The number of these positive charges will be always be equal to the number of these negative charges. Okay. Third point will be the ions carry the electric charge and they are responsible for the flow of electric current in the solution. Because we are talking about electrolytic decomposition, where not metallic decomposition, electrolytic. So that's why the ions have to flow in the form of cations and anions. Then the conductivity of the electrolyte depends upon the concentration. The key word is concentration, strong electrolyte or weak electrolyte. After that, the degree of dissociation is the extent to which an electrolyte dissociates into ions. So the key points: cations, anions. The number of cations formed is equal to the number of anions. The solution is in equilibrium, and it also depends upon the nature of the electrolyte, strong electrolyte or weak electrolyte. So this was the next question. We started with what is electrolysis, what is electrolysis. Then we started with what are the two types of things which are used in electrolysis. That is the conductors, metal conductors, electrolytic conductors. Then we started with what is an electrolyte, what are strong electrolytes, what are weak electrolytes. Then we came to what is a typical electrolytic cell, draw and explain the parts. Then we started with what are the two electrodes, the cathode and the anode. Then we came to the ions, the two ions, the cations and the anions. After that, with reference to chlorine and sodium. After that, we came to Arrhenius theory. What is Arrhenius theory? Until now, we were doing Arrhenius theory. Okay. So I am not writing those points here. Write it in your notebook. Now, the next question is: give the characteristic features of electrolysis. Features of electrolysis, very, very important. The characteristic features of electrolysis. What are the typical things which takes place in an electrolytic cell or in electrolysis? Now, first point which you should write here is the characteristic of electrolysis is, first thing which you should keep in your mind is the process of electrolysis is a redox reaction. First point, it is a redox reaction. Because why? Because loss and gain of electron is taking place. Where? Because at the two electrodes, at cathode and anode. At cathode, the electrons are being gained. They are gained at cathode. And what is happening at anode? The electrons are going away. The electrons are, the anions are donating their electrons there at the anode. The anions are donating the excess electrons at anode. Donating, get the oxidized. And at cathode, they are gaining, but they are getting reduced. So both of them take place together. So the first feature of an electrolysis is that the process of electrolysis is based on the redox reaction. Second point is, when an electric current is passed through an electrolyte, the positively charged ions that is the cations, migrate towards the cathode, and the negatively charged ions, that is the anions, migrate towards the anode. The number of electrons gained by anode is always equal to the number of electrons donated by the cathode. Then the products of electrolysis are formed at the anode and cathode, since the exchange of electron takes place only at the surface. So the products have to be formed here. Okay. The reaction at the cathode involves reduction of cations as they gain electrons to become a neutral, while the reaction at anode involves oxidation of the anions. You will underline the word reduction and oxidation. Reduction at cathode and oxidation at anode. And oxidation of anions as they lose electron to become neutral. So both of them are called the discharge reaction. So the example for example NaCl, if you want to write for NaCl, redox reaction for NaCl, explain with NaCl. How will you write the redox reaction? At cathode, what will take place? Na plus electron will become Na, reduction. Then if I want to tell for, this is at cathode, then at anode, Cl minus, Cl plus Cl plus Cl will become Cl2. This is oxidation. And overall reaction, is 2 NaCl will give rise to 2 Na plus Cl2. So this is a feature of electrolysis. Okay. Now we proceed to the next part. That is, now we will go for the comparison between the electrolytic dissociation of NaCl to that of, NaCl is the electrovalent compound, to that of a covalent compound HCl. NaCl versus HCl. Come to page number 106. This is the next heading. Electrolytic dissociation. Electrolytic dissociation of NaCl, very important. This salt, NaCl, very important. Now what will you write here? First thing you have to keep here in mind is, under what conditions does NaCl show electrolysis? Under what conditions? So the first point here is, sodium chloride is basically is a non-electrolyte. It doesn't allow electricity to pass through it, but when it dissociates in the molten state or fused state or in the aqueous state, then only it will pass or it will show electrolysis. And for this, the explanation will be given here. That is, sodium chloride will conduct electricity only in the fused state, that is molten state, or in the solid state. So their features are different. How in the molten state? What happens in the molten state to that of the aqueous state? Aqueous solution. Aqueous solution means it will be with water. So water, you know, water is a polar solvent. Water comes as this, oxygen comes as this, ionization, which if you remember your previous part, H2O, oxygen will be like this, and oxygen will be with a negative charge, hydrogen will be with a positive charge. Okay. Now this I will go partly. First I will go for the molten state. What will you write for the molten state? The ionic compound like NaCl contains two charges, two types of, it contains Na plus, that is the positively charged metallic ion, and the negatively charged chlorine ion. Na plus and Cl minus. First thing, it contains this. Then these ions are not free, but they are held together by a very strong electrostatic force of attraction, right? Because both are opposite. They have very strong electrostatic force of attraction. Due to this, an ionic compound in the solid state is a bad conductor of electricity because free ions are not available. Because free ions are not there to conduct electricity, and they are strongly held together with a very strong electrostatic force of attraction in the solid state. That diagram you should draw here. NaCl. Okay. Na plus Cl minus. Okay. Here you should write strong electrostatic force, very strong electrostatic force. This strong electrostatic force, when it is heated, when I will heat it, what will happen? When I will heat it, due to increased heat, they will break. Na plus Cl minus. They both will break. Free ions are found in the molten state. This is in the solid state, this is in the molten state. Your labeling and your diagram should be very clear. So dissociation of sodium chloride in the molten state. So when the ionic compound is strongly heated, the ions gain kinetic energy because of heat. They break and they get transformed into loose ions, and the molten solution thus becomes a good conductor of electricity. A very, very important question. Explain with diagram that how molten sodium chloride is a good conductor of electricity. This diagram should be given for that. Now, next question, next in relation to this will be what happens in the aqueous state, that is with water. Okay, now with water means water is a polar solvent, as I told you, water, H2O. This is the first part. The second part will be with water, H2O. Now, what happens here will be, water is a polar solvent first. The charge distribution of the molecule is H positive, O negative. Okay, now in water, each hydrogen atom develops a positive charge while oxygen atom develops a slight negative charge. So you will first draw this diagram like this to show H2O. Okay, then when sodium chloride is added, is dissolved in water, then what will happen? Sodium will dissociate into Na plus this plus NaCl. Before sodium is added to water, it will dissociate into Na plus and Cl minus. Yes, first thing. So then when sodium chloride is dissolved in water, it dissociates into sodium ions and chloride ions, which move freely in solution. Then what is the role of this water? Why we call it aqueous? What this water will do here? Now what this water will do here? This O minus, which is having negative, will develop a pull towards sodium. That is what I am telling you. This is due to the fact that the negatively charged oxygen atom of the water exerts a pull on the sodium ion, and a similar pull is exerted by the positively charged hydrogen towards the negatively charged chlorine, that is chloride ion. Right? Understand? And thus sodium and chloride ions become free in the solution because water is separating them, because they are getting attracted by the opposite ions here, NaCl and water. NaCl and water. Got it? That is how the reaction takes place in presence of water and in presence of heat. This was about electrolytic dissociation of an ionic compound, that is NaCl. Okay. Now we come to its comparison with the dissociation of a covalent compound, that is HCl. HCl we can take, or even any other compound, carbon tetrachloride, anything you will take. You will take HCl. Polar covalent compound. Something which has polarity. In chemical bonding, if you remember, polar covalent compound, where the electrons are equally distributed between the two components, polar and non-polar, if you recollect. So the polar covalent compounds are, for example, like what? Example like ammonia, hydrochloric acid, ammonia, NH3, hydrochloric acid. I am not talking about ammonium. Remember, not ammonium, not ammonium chloride. Talking about ammonia, NH3. How the bonding was shown in NH3. If you have seen the video of chemical bonding. Okay. Now the polar covalent compounds like ammonia, hydrochloric acid, and hydrochloric acid they behave as non-electrolytes in gaseous state. Remember, they are not electrolytes in gaseous state, but they ionize in aqueous state. They ionize in aqueous state in presence of water. So hydrogen chloride in the gaseous state or in the pure state is unionized and it doesn't conduct an electric current. It cannot conduct an electric current. Say if you have read the lesson acid, base and salt, dry HCl will not affect with litmus paper. But this dry HCl, when added with aqueous, when little water is added to it, then that acid with litmus will show a change, but dry it will not show because no ions will be there. So how the result will come? Okay. So hydrogen chloride is, however, a polar solvent in nature. It shows distribution in the molecule. How the distribution of molecule is there? HCl. HCl will be again H plus and Cl minus. Distribution of charges. Hydrogen chloride, polar solvent. And then when water is added, this plus water means water will be added, and water is, as you know, H plus and O. Okay. So water plus HCl will show what? Water plus HCl will show what? I write here the reaction with water. If water is being added to HCl, then what will happen? It will break into H plus. Why? Because H2O plus H will form H3O plus. This is known as hydronium ion. Hydronium ion and H plus is one and the same. H plus and hydronium ion is one and the same. Plus Cl minus. H2O plus Cl minus. You understand what I have shown here? Hydrogen chloride is a polar solvent. When water is added to it, the negatively charged oxygen of the water exerts an electrostatic pull on the positively charged hydrogen ion of HCl. The H plus ion combines with water, forming hydronium ions, and the residual chloride ions remain in the solution. Hence, ammonia or hydrogen chloride in gaseous or pure liquid state does not conduct electricity, but conducts electricity when it is dissolved in water. This is the reaction. So, I think I have given you a comparison between the electrolytic decomposition of NaOH to that, NaCl to that of HCl. And in the end, I would like to tell you the comparison between metallic conductors conduction and electrolytic conduction. It's also very nicely given. Say for example, if they ask you, give the comparison of copper metal, Cu metal as a conductor and CuSO4 as a conductor. This is also very important because Cu is a metal and CuSO4 is a electrolyte, salt. Electrolyte. Now what will you write over here? First is the flow of electricity takes place by flow of electrons in case of metals which have negligible mass. Second, there is no decomposition of the parent metal, and thus the chemical properties of the metal remain the same. No new product is found here. Metals are good conductors of electricity in the solid state but not and in the solid state and in the molten state. During metallic conduction, there is no transfer of matter. The flow of electricity only produces heat energy. No new products are formed, as I told you. And what about copper sulfate? When copper sulfate is taken as an electrolyte, the flow of electricity takes place with the help of ions. First, copper and sulfate, okay, which then there is decomposition of the electrolytic solution and the chemical properties of the electrolyte is altered. Electrolysis, these electrolytes are good conductors of electricity in aqueous solution and molten state, but not in solid state. During electrolytic conduction, there is transfer of ions, very important. There is transfer of ions, okay, because at the cathode and anode. And the flow of electricity decomposes the electrolyte and new products are formed here. So I am very clear with what I told you today. I want to conclude this first part of the video today with what I started. I started first with what is electrolysis, then what are conductors, what are two types of conductors, metal as a conductor and electrolyte as a conductor. Then came what is an electrolyte, what is the components of an electrolytic cell, what are strong electrolytes, what are weak electrolytes. Then came what are the features of an electrolytic cell, the comparison of anode and cathode with the differences. Then the ions, the anions and the cations, and how they get deposited. After that came what is Arrhenius Theory, his features. Then came what is the features of an electrolytic cell or electrolysis, all those points. After that I came to the comparison of NaCl to that of polar covalent compound NH3 and HCl, that comparison. And in the end I concluded with metal as a comparison between the metal conduction and electrolytic conduction. So I think this was the summary of the first part of the lesson, and the next part of the video will tell you about the electrochemical series. The electrochemical series means full metal, non-metal, that is all metals are electropositive, for that separate series. All non-metals are electronegative, for them the electronegative series, and which metal dissociates very easily, which with difficulty, same to form the cation, and the non-metal which one does very easily and with difficulty, the anion. And then will be the electrolysis of examples of some salt like lead bromide, copper sulfate, and after that I will also tell you the applications of electrolysis. First it will be electroplating, the basic process of electroplating, electrorefining, then electrometallurgy. And I think I am clear with my first part of the video, and thank you, and all of you go through the video, like, share and subscribe. Have a nice day.